Channel Main Engineer. Today we are going to discuss about types of function. So the first type is linear functions, second one is constant function, third one is identity function, fourth one is quadratic function, fifth one is inverse function, sixth one is composite function, seventh one is trigonometric function. So today we are going to discuss about all these 7 functions. So let's go for the first function, linear function. So for the linear function, we can say a function f is to a tends to b is said to be linear function if for all x is a member of a, y is a member of b. It can be expressed in the form of y is equal to mx plus c, where m and c is being constant. So if any function, if it can be expressed in the terms y is equal to mx plus c, then that function is called linear function. So let's give an example for the linear function. So example is f is to a tends to b is defined as y is equal to fx is equal to 2x plus 3. So as we can see here, this is the 2x plus 3 is in the form of mx plus c, where m is equal to 2 and c is 3. So as it is expressed in the this equation term, so this equation is called linear function, where a is equal to 1, 2, 3 and b is equal to 5, 7, 9, 11. So let's draw a graph and see if how the graph comes for the linear function. So as we can see, we can take the data from -6, -5, -4, -3, -2, -1 up to 5 and put in the equation. In terms of x, we can put those data, this all data, and we will get the value of fx. So these are the value of fx and these are the value of x. So let's draw the graph. So as we see, this is the x-axis and this is the y-axis. So for the x minus 6, fx is minus 9. So for the x minus 6, fx is 9. So this is the point. Then again -5, -7. So here -5, here is -7. So this is the point. Another is -4 and -5. So -4 and -5. So the same way you will get all this point. So when you join all the point, you will get a straight line. So as this is the equation of a straight line as well, so y is equal to, it is in the form of y is equal to mx plus c. So any equation if you find y is equal to mx plus c form, so those equation is called linear function. The next one is a constant function. So here comes the constant function. A function f is to a tends to b is said to be a constant function if for every x is a member of a, y is equal to fx is equal to c and c is the member of b. So if for all the input value output is the same, then that type of function is called constant function. So if any of the equation is in the form of y is equal to fx is equal to c, this form, then that equation is said to be a constant function. Let's give an example of the constant function. So let's take the 3 pair of set. So here f is equal to 1, 4, 2, 4, 3, 4 is a constant function. So if we draw this into the map, so we can see the first member is 1, 2, 3. Another set, let's say it have a member 4, 6, 8, but our output is 4, 4, 4. So 1 is going to be related with the 4, mapping with the 4, 2 is going to mapping with the 4, 3 is going to map with the 4. So as we see, all 3 members is just have a mapping with just 4, that means constant. So regardless of any of the input you get, the output always comes 4. That means output is constant. So this type of function is called constant function. Let's draw it in the map. So 1, 4. Let's say this is the x-axis, this is the y-axis. So if you give value 1, our output is 4, 1, 4. So for 2 it is 2 and 4, 2, 4. For 3 it is 3 and 4. So as you see, it also comes a straight line. So this is also a straight line, but it is a constant function. It will be constant on the constant function. It will always be a straight line. So again, the function is a constant function because the value is always 4 regardless of the input value. So it doesn't matter what are the input value, but the output is always going to be 4. So as you see in the line, this is always going to be 4 regardless of any of this input. So this type of function is called constant function. Let's discuss about the identity function. So a function f is to a tends to a is said to be an identity function if for all x is a member of a, y is equal to fx is equal to x. That means same input, same output. Whatever your input, you will get the same output. So in those conditions, that function is said to be identity function. Let's give an example. For example, a is equal to 1, 2, 3, 4. So f tends to a is defined as f is equal to 1, 1, 2, 2, 3, 3, 4, 4. As you see, same input, same output, same input, same output, same input, same output, same input, same output. So here, if x is equal to 1, y is equal to function of 1 is equal to 1. X is equal to 2, y is equal to function of 2 is equal to 2. Similarly, x is equal to 3, y is equal to function of 3 is equal to 3. All are in this form. Y is equal to x is equal to x. X is equal to 4, y is equal to f4 is equal to 4. So f satisfy y is equal to fx is equal to x. So f is in an identity function. Let's draw a graph. So this is our x-axis, this is our y-axis. So what is our first set up here? 1, 1. So 1 and 1. 1, 1. Another is 2, 2. So 2, 2. Third one is 3, 3. 3, 3. Same input, same output. 4, 4. 4, 4. So this graph is also a straight line graph. F satisfy y is equal to fx is equal to x. So f is an identity function. Let's draw this in the graph. As we see, 1, 1, 2, 2, 3, 3, 4, 4 are our 4 sets up here. Let's draw in the graph. So first one is 1, 1. So here 1, 1, 2, 2. Third one is 3, 3. So 3, 3 and 4, 4. So in this way we can draw. This is in graph as well. So basically identity function is the same if they satisfy this condition, y is equal to fx is equal to x. So let's try one example. So question is, if fx is equal to x plus 4, then prove that fx minus 4 is an identity function. So what is the identity function? If it satisfies y is equal to fx is equal to x, then we can say this function is a identity function. So let's take if this equation satisfies this equation. So given function fx is equal to x plus 4, what we have to find out? Fx minus 4. So we are going to put in x minus 4 as x. So here when x tends to x minus 4, we get f x minus 4 is equal to x minus 4 plus 4. We have to replace x into x minus 4. So here if we replace x into x minus 4, so x minus 4 plus 4, so same thing. So fx minus 4 is equal to x minus 4 plus 4. This 4 and this 4 is going to be cancelled, and remaining is only x. So fx minus 4 is an identity function because it satisfies y is equal to fx is equal to x. So let's come to the fourth function, quadratic function. A function f is to a tends to b is said to be an quadratic function if for every x is a member of a, y is a member of b, it can be expressed in the form of y is equal to ax square plus bx plus c. So if the equation is in the form of quadratic, then those functions are called quadratic function. Let's give an example. So y is equal to fx is equal to x square. As we can see, ax square plus bx plus it is in the form of ax square plus bx plus c, where a is 1 and b and c is equal to 0. So this function we can say it is in quadratic equation form. So and it is a quadratic function. Let's draw a graph. So we can take x as -2, -1, 0, 1, 2, and if we put those values here, we will get -2 square 4, -1 square 1, 0 square 0, 1 square 1, and 2 square 4. So this is the x-axis, this is the y-axis. So let's draw -2 and 4. So -2 and 4. So this is the point. Then -1 and 1, -1 and 1, then 0, 0, this one, and 1, 1, this, 1 and 1, then 2 and 4, 2 and 4. So this is the equation. This is the quadratic equation graph. So the fifth one is inverse function. Let f be the one-to-one function with the domain A and range B. Then the inverse function f inverse has domain B and range A, and it is defined by f inverse y is equal to x, or fx is equal to y for any y in B. So what we see, if the function is one-to-one function, then domain A becomes the range of B, and range of A becomes domain of B. So those conditions, this function is said to be inverse function. That means the domain and range interchange is position. So those function is called inverse function. But make sure the function must be one-to-one function, otherwise inverse function does not exist. Let's give an example. Before example, so note f inverse x does not mean 1 by fx. So for example, the inverse of fx is equal to x cube is f inverse x is equal to x 1 by 3. So this is the way we denote the inverse function. Note, f inverse f of x is equal to x for every x in A. So if you find the inverse function f inverse x, and again if you f inverse do fx, then you will always get your domain. All your domain means all the value of x, and f of f inverse x is equal to x for x in B. The sixth one is composite function. So let f is to a tends to b and g is to b tends to c be the two functions. Then the new function defined from a to c such that every element of a corresponds with a unique element of c is known as the composite function of f and g. It is denoted by gof or simply gf, and it is defined by the equation gof is equal to x is equal to g of f. So here there is a two function a b, f is to a tends to b and g is to b tends to c. So f and g are two functions, but and there are the three sets appear a, b and c. So if the function we can denote from a to c, then those function is called composite function. So let's give our examples to be clarify more. So here f is considered to be dependent function and g is considered to be independent function. Then let's give an example. Let's say three set appear a, b and c. So as we see, this is the set a, this is the set b and this is the set c. So f is to a tends to b means f is a function of a and b, and g is to b tends to c means g is a function of b and c. So if we consider the function from, if we calculate the function from a to c, then that function is called composite function GOF. So there is also every member of A is going to be associated with every member of C, and that function is denoted by gof or g of fx. So that function is called composite function. Here comes the trigonometric function. So our function happens to A tends to B is said to be a trigonometric function if the function f involve trigonometric rations. So sine, cosine, tangent, etc. For example, if y is equal to sine x, y is equal to cos x, y is equal to sine x plus cos x, etc. are the trigonometric function. That means if your equation is the form of y is equal to sine x or cos x or sine x plus cos x, so this forms of equation is called trigonometric function. So let's draw a graph of the trigonometric function. So let's take y is equal to sine x. So here you see sine x. So you have to put the value of x in the terms of angle, like sine 30, sine 45, sine 90, sine 60, sine 75. So those type of angle you have to put in the x-axis, and then you will get the value of y-axis. Okay, it's the same way in the cos x also. You have to put the value in the degree, and you will get the value of y. So make two charts, one with the degree and one with you will get the fx value. So in this way you can draw the graph for the trigonometric function. So thanks for watching. For any question or suggestion, please email us at remainengineers@engineer.com.